and we might find you know, a whole bunch of people, you know, weighing between 100 and 200 pounds. But then we also have a few people weighing maybe a lot more than that. And then we might even have a couple people weighing a lot more than that, like 400 pounds, okay? Not very many, but we might have something that looks like this, okay? So most people are over here, and we have a few out here. And we might call these outliers. And this, so this would be represented with something like this, and we would call this the tail of the distribution. Okay. This would be unimodal because there's also only one peak, but we would call this right skewed. So right skewed means you have a few that are much larger, but if you go in the opposite direction, nobody exists. So if we say, you know, this is like the middle or the average, let's say the average weight's around 160 pounds, do we have somebody, are there people who weigh 320 pounds? Yes, okay, not very many, but 320 pounds is 160 pounds above average. If we go 160 pounds below average, what weight is that? 0 pounds. Does anyone weigh 0 pounds? No, impossible, okay? So you would have nobody that far on the other side. Okay. So if this is called right skewed, what would a distribution that looks like this be called? Left skewed. Good. You guys are all detectives here. All right, and if you need help remembering this, okay, just imagine cutting this out, and you're going to skewer something or stab something. Which side would you use to do the stabbing or the skewering? Over here you would use the left side, the tail, and over here you would use the right side. These are all unimodal distributions because they have only one peak. We might have a distribution that looks like this, and this would be called bimodal. What's a distribution? What's a variable that might look bimodal? Okay, pause. All of these distributions, these curves I'm drawing, represent histograms, right? And what kind of variable are we dealing with here? Numeric variable. Okay. Resume. Bimodal distribution. Can you think of a variable that might give us a bimodal distribution? Sleep patterns?
Heart rate, income, or...
Okay, so actually income's a good question. What kind of distribution would income be? It's not, I'll tell you, it's not. It's going to be right skewed, okay? Most people make around, you know, between 10,000 and 100,000 a year, okay? The bulk of America makes between that. Do you have some people making $1 million a year? Sure, okay? But, and $1 million per year is 900,000 or, you know, 950,000 more than average, okay? Or something around there. Does anyone make 950,000 less than average? No, okay? Wow.
Not for long.
Yeah, you won't be making negative money for very long. I mean, it's possible. Okay, bimodal. So again, we're dealing with a numeric distribution, okay? A numeric distribution. So think of, you're taking, you know, think of the table where you're collecting data, and when you're collecting data, you're getting a whole bunch of answers around one number, this peak, and you're getting a whole bunch of answers around another number. So this could be something like testosterone levels in people. Okay? Testosterone levels is measured in something like micrograms per deciliter of something that in your blood or whatever. Okay? Everybody produces some testosterone, okay? Women produce testosterone, men produce testosterone. But if you look at the amount of testosterone the average woman creates, it's going to be somewhere down here, okay? Some women make more testosterone than other women make less testosterone than other women, but the average amount for females is somewhere around here. If we look at men, men generally create more testosterone than women, and the average testosterone is around here. Some men create more testosterone than others, some men create less testosterone than others. But generally, you don't have very many people in this no man's land where this is either going to be a woman who creates unusually high testosterone for a female, or a man who creates unusually low testosterone for a man, okay? And so you're going to have this two-peaked distribution bimodal. Does that make sense?
So would you have to be surveying two different kinds of things in order to get the...
No, we're only surveying one thing, which is how much testosterone do you
Well, I
make?
meant the men versus women thing.
Yeah, I mean, there's probably some kind of subgroups within the population to explain this type of thing, okay? And this is, I think this is now how the Olympics determine whether you are a man or a woman if your gender is called into question, okay? Life is complicated, right? I mean, it used to be you're either a man or a woman, and now, you know, it's not, okay? I mean, you guys laugh, but, you know, for some people that this is a very serious issue, and you know, right, like, what's the answer? And there's a lot of questions, right? There's like a female MMA, genetically born male, went through changes, medical operation, female, competes as a female. People question, is that fair? Is that, okay, so it's different, you know, the MMA said, oh, you can go as female, and other people said, I don't know, okay. These are all sorts of questions that society will have to figure out an answer to. What time is it? Oh, shoot, okay. All right. We have to discuss measures of center, okay? So these are now for numeric variables, okay? We're dealing with a numeric variable. And someone might ask, what is the average, or what's the center? Okay. Well, we have two numbers. We have the mean, and we have the median. I think you guys are familiar with both of these terms. Okay. Is that the mean is where you take all of the numbers up and you divide by how many numbers you have. That's the mean, okay? Symbolically, we write the sum of each number divided by how many numbers we have, okay? This basically says, on the top, add up each number, or each y, or each number you have. And then when you write a bar, you're making a fraction, you're saying divide by n, which is always your sample size. Sample size, or how many numbers you have, that's your sample size, n. Visually speaking, the mean is the balance point, okay? So let's say you have a histogram that looks like this, okay? Assume this line has no weight whatsoever, and these are, you know, stacks of bricks or something. Where is this thing going to be balanced? It's going to be balanced right there, okay? This would be the mean. The mean is the balancing point. Okay. If you have something skewed, let's say I just stick on one brick over here, how's that going to affect the mean? It pulls it over this way, okay? Just so that the thing can stay balanced, right? Okay, so the mean, if I include this, gets pulled over. The median, on the other hand, this is the halfway point. Half of the data points are larger, and half are smaller. Okay. So if I stuck on one piece over here, okay, so I still have this one piece way over there and one piece here. Where would the mean be? The mean would still be pulled over in this direction, right? The mean would be somewhere over here so that it can stay balanced. But where's the median? The median is still right here. So this is the median, where half are bigger and half are smaller. But the mean gets pulled out because it's the balance point. Yes, question?
So the median is less prone to skewed distributions?
Yeah, the median is not affected by outliers or skewed distributions, yeah. The mean is, okay. Median is our halfway point. Half are larger than the median, half are smaller than the median. If you were given the task of finding the median, the first thing you would do is you would put them in order from least to greatest. And that way you can find the halfway point where half are larger and half are smaller. You'll have, let's see, I've got just a few minutes left. Okay, I'm assigning problems from 2.4, which is the construction of box plots. If you read section 2.4 carefully, I think it will make sense in constructing box plots. The keys there, in addition to finding the mean and the median, you will need to understand quartiles. Okay, we have Q1, Q3. Technically there are 4 quartiles. Okay, the median is where half are bigger and half are smaller. Quartiles, Q1 is where 1/4 of the data is smaller. Q3 is where 3/4 of the data is smaller. So Q2 would be where 2/4 is smaller, and that would be what? The median, because half is smaller. Okay? So Q1 is where 1/4 of the data is smaller. 1/4 of the data is smaller than Q1, and Q3, 3/4 are smaller. The book, I feel, does a good job of explaining how to find the median, how to find Q1 and Q3. Essentially, you put your numbers in order from least to greatest, you find the halfway point, that's your median. Once you find your halfway point, then you just chop this half in half, and that's going to be Q1. And then if you chop this half in half, that's going to be Q3. That makes sense, right? Okay. How much of the data is between Q1 and Q3? 1/2, 50%, right? Q1, 1/4 is smaller, but 3/4 is larger. Q3, 3/4 are smaller. So how much is basically between the 25th percentile and the 75th percentile? 50%, okay? Q1 and Q3. Okay, let me just, I know I'm running out of time, and I might even go a couple minutes late, and I hope you forgive me. If you've got to take off, you got to take off, and I won't hold that against you, because I know it's my bad for going late. we also have measures of spread. Okay. Measures of spread, we are talking about how similar are the numbers or how different are they, okay? So for measures of spread, we have things like the range, the IQR, which is the interquartile range, and the IQR, you find the IQR by doing Q3 minus Q1, also explained well in the book. And lastly, the standard deviation. And I have a video describing how to find the standard deviation. Okay. The key thing is that all of these numbers give us an idea of how spread out our numbers are or how similar our numbers are. Okay? So let me give you an example here, okay? If we asked everybody in this room, how tall are you? We would see a range of answers, okay? Some people are tall, some people are short. We would get a decent range of answers. If we asked everybody here, how many fingers do you have on your left hand? Okay? We would not see a wide variety of answers. Almost everyone would say 5, okay? But there might be someone with a different number, okay? And so these measures of spread would indicate for height, we would have, maybe a range of 12 or something, okay? Indicating that the difference between the tallest person and the shortest person is 12 inches. It's probably even larger than that. The interquartile range also is just another way, would indicate that we have some kind of spread here. And the standard deviation also, these are all just different numbers that indicate how different the numbers are from one another. When we look at the other variable, how many fingers do you have on your left hand? Okay, it's a numeric variable with values between 0 and 8 or 10, I don't know. I don't know how many fingers possible, okay? But almost everybody would have 5 fingers on their left hand, and so all of our measures of spread would be quite small. The range might be 0, meaning that there's no difference between the largest number and the smallest number that we observe in this classroom. If somebody doesn't have 5 fingers on his or her left hand, then the range might be 1 or 2, okay, or 3 if somebody, depending on what that is. The standard deviation, again, would be quite small if there is no difference between, if everybody has 5 fingers on their left hand, the standard deviation would be 0, meaning that there's no difference between any of these numbers here, okay? If we ask another question, such as, so height, we would see a decent range. If we asked, what is, how wide is your hand, and we measure from, we have you spread out your hand, we measure from here to here, we would also see a wide range of values, but the range will not be 12 inches or something, okay? Okay, so measures of spread give us an idea of how similar or how different there are. In your reading and in your homework, you'll be quizzed on, or not quizzed, but asked to calculate the range, the IQR, and the standard deviation. I apologize that we didn't have time to go over the examples of calculations ourselves in class. I feel that the book does a good job to answer these questions. And again, I have recorded video solutions to calculating these things yourself according to the methods explained in the textbook. And again, if you have any questions beyond that, don't hesitate to ask. or post questions on Facebook or via email. Okay? Good luck, you guys. We'll see you guys next week.